Thank you, David. Just by way of introduction, my name is Harish Malkani. I'm the CTO of CESMII, the Smart Manufacturing Institute. I think the logo that you see here is a recent rebranding, so if you go on the website, you still probably won't see this. It's going to be up in a couple of weeks. My background has been mostly in technologies that kind of make up smart manufacturing. So when you talk about things like sensing and process control, process modeling, analytics, that has been my background for the last 30 years. Before I joined CESMII, I was with the Alcoa Research and Development facility in Pittsburgh. So there's a connection here between the two speakers. As of last March, I joined CESMII as their CTO. So glad to be here. Thank you for being here. Before I start, how many of you have actually heard of this particular institute? So that I can, okay, maybe a few of you, yeah. Okay, great. So what I'll do is I'll just begin with a high-level video that kind of introduces the institute. It's just a 1-minute video, so it's not something that you'll fall asleep on, hopefully.
Welcome to CESMII, the Smart Manufacturing Institute, manufacturing's voice of innovation, powering the smart manufacturing movement. As an energized ecosystem, we are unique. We work tirelessly to drive industry's productivity and competitiveness ahead in the United States. We are built upon the network of our dedicated members' active leadership and engagement. At CESMII, we see a way forward, and we recognize industry's need for a clearer, more actionable vision for the smart, data-driven future of manufacturing. Growing manufacturing's productivity, sustainability, and competitiveness. We seek to revolutionize manufacturing by obliterating the barriers for rapid change and innovation. Manufacturing of tomorrow is an exciting space where the innovators, the trailblazers, and the makers all thrive, and where our brand is truly home.
Okay, so CESMII as an institute, like David mentioned, is one of the 14 institutes that's been put up by the federal government. Each institute has a focus area that has been given as part of their charter. For us, our focus is around improving energy efficiency in manufacturing through technologies that are known as smart manufacturing technologies. And like I said, it's sensing, control, modeling, analytics, and platforms. The institute was founded in 2017. We are getting started. We had a bit of a pause for a few months, but the institute is now under the auspices of UCLA as a parent institution. And we are just about to launch off several projects this month worth about $16 million in funding. Again, it's a public-private, $140 million is the total funding available for the next 5 years, out of which 70 comes from the Department of Energy. And like David said, there are other institutes that have funding coming from Department of Defense for comparison. The $140 million here is just a drop in the ocean for the $150 billion that Walter talked about in terms of the investment that the federal government is making. We don't have a product to sell. I mean, we thrive on our network of members that bring in the expertise and the technologies that make up smart manufacturing. So at the end of the day, we are all about networking, as David said. We are all about bringing an ecosystem together that helps us develop those technologies. One of the things that we're trying to do is a theme called democratizing smart manufacturing. And to that effect, our membership model has been dramatically changed as of just a month ago, actually, where we'll be enabling many small, medium manufacturers to come and join our ecosystem. So that's the charter going forward for us. And again, we are again, like I said, the ecosystem is going to actually deliver the technologies and help proliferate smart manufacturing technologies through our manufacturing systems in the country. So we, as an institute, we've developed a roadmap with four integrated pillars. Two of the pillars that are on the right-hand side are around technology. The first one is about enabling technologies. So when you talk about solutions that make up sensing and control and modeling and so on, those are all enabling technologies. But then the other one on the bottom right is the smart manufacturing platform. So it's not just about developing those technologies, but how do you make those technologies available and accessible for everybody in the manufacturing space in a cost-effective manner. So our charge is to develop that platform where people can plug in their technologies, people are able to use those technologies at a very low cost. And on the left-hand side are the two other pillars that are non-technical, but equally important. One is around workforce development. A lot of these institutes have that as the pillar, and that's a great thing because we can actually cross-communicate across these institutes around workforce development. And the other one is around business practices. So these are all the four pillars of the roadmap. And what we've done in the roadmap is to identify near-term, mid-term, and long-term opportunities that exist in this space. So you're welcome to go on the website and look at the roadmap, but you'll see the flavor of what we have in the roadmap. And the idea is to take that roadmap and then launch off projects that will help address the elements of the roadmap in the 5-year time frame that we've been given and beyond. So the idea about democratizing smart manufacturing falls into basically three buckets, right? Talk about democratizing knowledge. So this is about getting the entire manufacturing ecosystem the ability to learn about what smart manufacturing is and how it can be applied to the manufacturing processes. How do you train your workforce to become ready for this Internet of Things and the Industry 4.0 that you hear about, right? All the more fourth industrial revolution technologies. So that's the one piece. But the idea there is to how do you make it simple? How do you make it addressable so that you're looking at the workforce at all different levels, the people who touch and feel the process, the people who are at the engineering level and the management level, the people who are in the C-suite in these companies. How do you bring the level of knowledge up? The other one is around enabling technologies and platform. I briefly talked about this. So how do you get the actual technologies that help manufacturer become smart? And how do you make that accessible and available? That's all about democratizing technology. And the last one is making it collaborative to innovate, right? So this is where I talked about the ecosystem. We're not going to be tied down to a specific technology or a specific vendor, but develop an ecosystem where everybody can play together and everybody are able to use the technologies that are developed. So that's the theme around democratizing. So what do we mean? Many of you may or may not be familiar with what smart manufacturing actually is defined as. And at the very fundamental level, it's essentially the use of information to make smart decisions, right? So, and the information has to be the right information at the right time, delivered to the right people or the right machines, so that those decisions can be made, either by humans or by machines, right? That's essentially what it is. So when you hear the word Industry 4.0 or the fourth industrial revolution, it's about how you leverage information to make things smarter, right? So what are the building blocks that make up? If you think about a manufacturing process, the first thing that occurs in terms of making it smart is to obtain information from it automatically, right? So that's all about sensing, right? When you install sensors on your machines in your manufacturing flow paths, you get the data from that process. But that's not enough, and the reason it's not enough is that if you put a thermocouple that measures temperature somewhere in your process, unless and until you know where that temperature was measured, when it was measured, how it was measured, and how it relates to the product or the manufacturing process, that piece of information is just a number, right? So developing a context around that data becomes very important. And that's the piece on the left-hand side, contextualization. And once that is done, then you have information that becomes actionable, right? So that's a very central theme of what we're trying to accomplish. And then once you have the information, then you can route that information multiple ways. You can use it back into your control system to control your process better. You can do some advanced analytics on it to understand why things are happening. You can develop some intelligence based on modeling and predictive analytics and so on to understand when it could occur next and how you can prevent that from happening or have more of that happening. So that's all the right-hand side of the picture. So if you go from left to right, you're going from a reactive mode to a more proactive mode, and then looping it around for your manufacturing process. So these are all building blocks of smart manufacturing. And one of the things that I will mention here for my colleague who's from the Robotic Institute is that automation is sort of a foundational piece, right? So when you think about a process, when you think about sensors and control, that's all about automation. Robotics is all about automation. So they go hand in hand. So as you hear from him later on, you'll try to, you'll see how that kind of connects up. Sorry, one more point I wanted to make here was that the arrows between these blocks are equally important. And this is all about information that needs to flow between these systems at a level and in a manner that's not taking you weeks and weeks and weeks to kind of put stuff together so that information can be transferred between these, right? And contextualization becomes an important piece for that. So what we've done is we've looked at how do you make that happen, right? How do you connect all of these pieces together in a fashion where you have a platform that enables multiple players to play into the ecosystem? So at a very base level, the first ability is the ability to connect to your manufacturing systems, connect to your data sources, right? So that's the bottom layer of this picture. And there are tons of solutions out there. There are tons of vendors who come and give you the solutions to connect back into your machines, right? The next piece, as I said, is contextualization. This is where a lot of subject matter expertise needs to come in. So the data that's coming from your machines, from the people on the manufacturing shop floor, it needs to be put into context. What does it mean? And this is where a lot of subject matter expertise comes in. So if you're trying to do this for a aluminum parts maker versus a automotive assembly line versus an aerospace manufacturer, the context of that data changes, and you need people from those manufacturing entities to provide that context. Right? Once that is done, that information that is collected can be sort of modeled and stored and made accessible for consumption, right? And the consumption then happens through what we're calling a marketplace of applications, right? So if you have a person at one of the universities who's the brightest person who has a machine learning algorithm that's just out of this world, that person can now bring that application back into this ecosystem and make it work for the manufacturing applications, right? So it's all about how do you define the use cases, bring these applications into a marketplace, and then let the users use the applications with the data that's coming from the manufacturing floor, right? So it's a pretty critical piece of this particular system platform. So how does the Institute actually work with these enabling technologies and the platform? So if you look at this diagram here, on the left-hand side, it's all about the development of these technologies. And you look at the ecosystem, whether it's the academia, whether it's the manufacturers, whether it's the technology vendors, they help develop the fundamental technologies that are essential for this, right? In the middle is the platform. So these technologies make their way into the platform so that they can be used by our manufacturers, right? But that doesn't mean that you need the platform all the time to make those technologies available. You can actually take the enabling technologies and have a technology transfer between that and a manufacturing user, right, without the platform as well. So you can take those pieces and make them work. But it's essential that as you drive it through the platform, we have a feedback loop that says, as you begin to proliferate these technologies and as manufacturers start using the technologies, you have a feedback loop that comes back and say, hey, you have not addressed this particular gap, and here are things that are pain points for us go back and feed it back into the system on the left-hand side where you're beginning to develop those technologies and fill those gaps, right? So we have a loop that's a pretty critical part of this, this whole ecosystem. So let me talk a little bit more about the platform itself.
Data access isn't the problem anymore. We've got all the data we can handle, more even. But how do we use data to create change and benefit from it without the context so necessary to create real value? The CESMII platform will dramatically reduce the cost and complexity of extracting meaningful, contextualized data from real-world industrial assets. By building data profiles of industrial devices and crowdsourcing extensive libraries of these profiles, we solve problems, simplify the complex, and drive innovation globally. It's plug and play for industry with all its industrial devices, machines, systems, and processes. Let's say that a system integrator in Chicago builds a particular robot profile, and a data scientist in California builds a predictive model for that same robot. The CESMII platform and marketplace now allows every manufacturer across America to access both that profile and predictive model and have their systems up and running in a matter of minutes. Harnessing the world's domain experts by giving them the tools to share their insights and obliterate the technology barriers so that data can flow and transform plant operations. A smarter, cleaner approach to manufacturing will lead to greater efficiency, increased productivity, and the ability to stay competitive in an ever-evolving global manufacturing landscape. CESMII, the Smart Manufacturing Institute.
Just full disclosure, the robot example was built into the video way before I knew that Jay was going to be here from the Robotic Institute, so, okay. So just very briefly, our membership, don't expect you to read this, it's on the website, but we do have a mix of industry, academia, technology vendors that make up our ecosystem and our membership. We have 102 members currently, and we are expecting that to grow rapidly in this coming year through our new membership model. So I'll just kind of flash these, and you can recognize some of them, but welcome to, I think these slides are going to be available for the community. So my last slide was around, so all this stuff is great, but the reason you all are here is to find out how you can engage with the institutes and how the institutes can engage back with you. So I tried to articulate this in just one slide here. So the piece around technology development, I've had some conversations with a few of you over the last months and found out that there are a lot of cross-cutting technology areas that the federal labs are working on that are very, very relevant for some of these institutes. And for us in particular, there are many programs going on in the federal labs that are directly connecting with either things like being able to predict things from a process or high-performance computing or specific areas of sensor development that are actually applicable for manufacturing. And those are all great things to have heard because I feel like there's a great potential between the institute and the federal labs there. So if you look at things like cross-cutting technologies on sensing or modeling, that's certainly a piece on the left-hand side of this diagram. And then on the right-hand side is a piece that I think is sort of estimated and underutilized, which is that how do we take output of our institutes and actually go back and demonstrate it using the federal facilities that we have out there. It's a very powerful aspect of it. And the last piece is around the high-performance computing. As we think about the platform, there are many things that we need to leverage that are already out there. We don't want to reinvent them. So the ability to do high-performance computing as part of our platform is a strong connection as well. So hopefully these are just three examples of how I personally see the connections between them, but maybe there are other ideas that you might have that I'll be willing to share and